Hi everyone, welcome to this tutorial session. Let us solve this exponential question, this math Olympiad question from China. Root 2 to the power root x minus root 2 to the power root y is equal to 60. Solve for the value of x and y. So please watch carefully, follow the solution carefully from the beginning to the end. And if there are any worries, please don't hesitate to indicate anything, any question or any worries in the comment section. Let us begin. Root 2 to the power root x minus root 2 to the power root y is equal to 60. To solve for x and y. Now, the first thing to do is let us convert this root 2 to the power half. We all know that square root means power half. And so this equation will be rewritten as 2 to the power half into root x minus 2 to the power half into root y is equal to 60. This gives us 2 to the root x all over 2 minus 2 to the root y all over 2 is equal to 60. Okay, so this is what we get. Now, we want to make our equation less bogus. To do that, let us bring in new variables, m and n. Okay, so that will make our equation look less bogus, not occupy much space. So let us call m to be root x all over 2, this first power, and call small n to be root y all over 2. Okay, all right. So what are the conditions for m and n? We know that m and n must be natural numbers. How? Why? Because we have the difference of two exponential equations, difference of two exponential expressions giving us a natural number. 60 is a natural number. So the only condition for this to be true is that this power and this power must also be natural numbers. So that's why m and n are natural numbers. All right. Next thing, we also see here that we are actually carrying out subtraction. The bases are the same, base 2, base 2. Now this expression, this index expression minus this index expression giving us a positive natural number supposes that this power root x all over 2 must be greater than this power root y all over 2. Okay, for us to be able to have a positive natural number here. Okay, so we can also therefore then add the other condition that m must be greater than n. All right, that said, if m is greater than n, then we can also say, we can write m as n plus some other natural number k. Okay, we can write m as n plus some other natural number k since m is strictly greater than n. Okay, that makes sense. All right, if that is written, then we will now rewrite our equation now in terms of, first of all, in terms of m and n. Our equation, since m is this and n is this, our equation becomes 2 to the m minus 2 to the n is equal to 60. Now when we replace m with n plus k, following our reasoning, we obtain 2 to the n plus k minus 2 to the n is equal to 60. This is what we get. All right, this, you can see 2 to the n is common. All right, remember, power n plus k means 2 to the n multiply to 2 to the k. Okay. From here, we can see that 2 to the n is common. We can factorize out 2 to the n. 2 to the n into 2 to the k minus 1, giving us 60. All right, we have product of two index expressions giving us 60. Okay, now there's another line of reasoning that we must follow here, because now that we have the product of two expressions giving us 60, we have to decompose the number 60 and form two equations. But how do we go about that? Okay, when we decompose 60, what is the pair of what are those factors of 60 that will match what we have on the left hand side? Now, if you look at the left hand side, we notice the following. 1, 2 to the n is always even. Okay, it's always even. 2 raised to any power will always be even. And then number 2, 2 to the k minus 1 will always be an odd number. Okay, an even number minus 1 will always give us an odd number. For example, the number 6 is even. 6 minus 1 will become 5, which is odd. All right. Okay. So, or let us take powers of 2. The number 8, which is the same as 2 to the power 3. 8 is even. But 8 minus 1 is 7, which is odd. Okay. With that now at the back of our minds, let us now decompose the number 60, knowing that the choice that we're going to make, one of the factors will be have to be even, and then the other factor has to be odd. So let's decompose 60, the number 60. Decompose the number 60. To do that, we can have 60 as 1 times 60. We can have it as 1 times 60. We can also have 60 as 2 times 30. We can also have 60 as 4 times 15. We can also have 60 as 5 times 12. So these are the possible decompositions of the number 60. So which of these decomposition will perfectly fit our left-hand side expression, which says that one of the factors must be even, the other one must be odd. So uh, if we look at this one, yes, this is odd, this is even, all right. Now, what about the second decomposition? 2 times 30. This is even, this is even. So automatically, this choice is out of place. All of them are even. We're supposed to have even and odd. Come over here, we have even, we have odd, yes. Coming over here, we have even, 12 is even, and 5 is odd. Well done. So now, which of these other three decompositions now will match the left-hand side of this expression? That is our next level of thinking now that we're going to summon. We're going to summon that level of thinking to come up with the rightful choice. Now let's take the first one, 1 multiplied to 60. If we take 1 multiplied to 60, if we take 1 multiplied to 60, two to the n into 2 to the k minus 1 equals 60. If we say that we want to take, this is supposed to be even, so 60 times 1, this is supposed to be odd. Okay, if we are taking this choice, 60, 1 times 60 or 60 times 1, this is even, yes, 60 is even, this is odd, yes. Now, what are we then saying? We are therefore saying that 2 raised to the power n must be 60. Do we have any power of 2 which is 60? Do we have any power of 2 which is 60? There is no power of 2 which is 60. There's no natural number n such that 2 raised to that power will give us 60. So automatically we see that the choice 1 multiplied to 60 is also cancelled. That's not a good choice. Okay. Now let's take the other choice. Let's take the other one. Let's take the other choice. 4 multiplied to, or 5 multiplied to 12. Let's take this one first. 5 multiplied to 12. Therefore, we'll put the even number where we have even, and then the odd number where we expect odd. Alright, this even go with even, odd go with odd. Now, the same type of reasoning. Do we have any power of 2 that will give us the result 12? Do we have 2 raised to any power that will give us the value 12? There is no power for which when we raise 2, we're going to obtain 12. So this choice also now is also eliminated. That choice is eliminated. So we are left just with the choice 4 multiplied to 15. That's the choice that we have finally. 4 multiplied to 15. So we will now write it in the place of 60. Alright, let's work out that one. So 2 to the n into 2 to the k minus 1 is equal to 4 multiplied to 15. Alright, so we have this product giving us this product. Even go with even, and odd will go with odd. So let's form the two equations. So we're saying 2 to the n should give us 4. This is an index expression, the base is 2. We can change 4 to 2 to the power 2. So that when we have 2 to the n is equal to 2 to the power 2, alright, 2 to the power 2, then we can safely say that the value of n is 2. The value of n here is 2. Alright. Now let us take the other equation. Let us take the other equation. We now take this one, 2 to the k minus 1 equals 15. 2 to the k minus 1 equals 15. To solve for the value of k, we take the minus 1 from the left hand side to the right hand side. We obtain 2 to the k is equal to 15 plus 1. 2 to the k will be equal to 16. 16, we know it is 2 to the power 4. So we have 2 to the k is equal to 2 to the power 4. So from here, since the bases are equal, we just equate the powers. So k is 4. Okay, so we found the value of m and k, n and k, but we don't forget where k came from. K came from the relation that m is equal to n plus k. Okay, so we want to get the value of m. Now this therefore means that we're going to have 2 plus 4. So the value of m is going to be 6. The value of m is 6. Now, we also remember our question was not given in terms of m and n. It was given in terms of x and y, and we're asked to find the value of x and y. So what is the relation between m, n, x, and y? We had it earlier. That m is equal to root x all over 2. And we just found that m is 6. So we'll put 6 is equal to root x all over 2. So when we cross multiply, we have 12 is equal to root x. To remove the square root sign, we square both sides. And so we're going to have x is equal to 144. So the value of x is 144. Now what about the value of y? Okay. Also, we add root y all over 2 to be equal to n. But we found n to be 2. And so we're saying root y all over 2 is equal to 2. When we cross multiply, we have root y is equal to 4. When we square both sides, we obtain y is equal to 16. So the value of x is 144 and the value of y is 16. Now let us verify to be sure of our solution or our results. Let us verify to be sure. This is the value of y, that's the value of x. Let us verify. Now, to verify, we have 2 to the root x. That gives us 2 to the root 144. That gives us root 144 is 12. That gives us 2 to the power 12. But this was divided by 2. So we divide all through by 2. It gives us 2 to the power 6. And 2 to the power 6 is 64. Now we also now have 2 to the root y divided by 2. This gives us 2 to the root 16. Y is 16. 2 to the root 16 divided by 2. Root 16 is 4. So we have 2 to the 4 divided by 2. That gives us 2 to the 2, which is 4. Alright? Now, if we put it here, if we put those two values here, okay, this value and this value, if we put that down, those values in our original equation, do we have complete agreement? The left hand side agreeing with the right hand side. Okay, so if we put them there, are we going to have root 2 to the root x? We found that to be 64. Do we have 64 minus root 2 to the root y? We found that to be 4. Do we have 64 minus 4 equal to 60? True. Therefore, our solution x equals 144, y, our solution x equals 144, y equals y equals 16 are valid solutions.